Welcome to Study Loop.
Once again, welcome to a new problem. This time we have a bullet and a block. So we're given a scenario where we have a 5 gram bullet. So mass of bullet is 5 grams. We're going to change that right away into kilograms, and we multiply by 1 kilogram over 1,000 grams, and that gives us 5 over 1,000, which is 0.005 kilograms. So this is a bullet that's moving that way, and there's a block. There's a hanging block right here, and the bullet is going to collide with the block. So this is kind of like the before scenario. And think about this as an axis, an extended axis. You can even have the y-axis right there. The block itself has a mass of 1 kilogram. It's a block of wood. Okay, so we'll just call it mass of wood is 1.00 kilograms. So that's what's happening. We're also given that the initial velocity of the block is going to be 450 meters per second. So that's the information we're given. We're also given that once the bullet collides with the block, something happens. So the this is the block right here. So once the bullet collides with the block is gonna be lifted up a new height of 0.38 centimeters. I mean, that's pretty small displacement, but we have to expand it just to show what's happening right here. So the block gets lifted. So right now, if it happens to be here, you can see that there's a change in height for the block. So this distance right here is 0.38 centimeters. We can change that to meters by multiplying by 0.38 centimeters times 1 meter of 100 centimeters, and this becomes 0.0038 meters. The center of gravity rises by the same amount, so 0.38 centimeters. The bullet is going to go inside the block, and it comes out on the opposite side. So the bullet emerges on the opposite side. Initially, it was on this side, and then it goes on the other side. And we want to find the final velocity of the bullet. Given that the block will be moving, it means that it's also going to have its remember the initial velocity of the block. The initial velocity of the block is 0 meters per second, and then the block also has a final velocity once you strike it, but we don't know what the final velocity is, and we also don't know what the final velocity of the bullet is. But we're going to find out. The purpose of the problem is to solve for the final velocity of the bullet as it comes out, or the speed of the bullet as it comes out. So in the next page, we know that by the law of conservation of energy, law of conservation of energy, I think we have to go back and we're interested in finding the final velocity of the wooden block, and that's going to help us with the law of conservation of energy. So the kinetic energy of the wooden block. So the initial kinetic energy plus the initial potential energy equals to the final kinetic energy of the wooden block plus the final potential energy of the wooden block. We know that the initial height is 0, so this one is just going to be 0. The final kinetic energy also is going to be 0 because as the block rises, its final velocity will be 0. So these two are 0. So then we have a 1/2 mass of wooden block velocity, initial velocity of wooden block squared equals to mass of wooden block, g, and final height of wooden block. And so we're supposed to solve for this velocity. We're supposed to solve for this velocity. I think we have to change some numbers here. The final velocity of the wooden block is 0 meters per second. What we don't know is the initial velocity of the wooden block. So that's what we need in this case. Remember, it swings. So initially, we don't know what that velocity is, but we know that it's going to swing up until it gets to a certain height and then it stops. So we need to find this initial velocity. And so we solve for that. Vi squared equals to multiply both sides by 2 and then divide both sides by the mass of the wooden block. These two cancel out and these two cancel out. Those two cancel out. And we're left with g, final height, twice. And so the initial velocity of the block is just what we call 2g, the final height. And remember, the final height is this one right here. This is the final height of the block. So we have that. And then in the next page, we'll use the law of conservation of momentum. Our goal is to find the final speed of the bullet. So law of conservation of momentum says that the initial momentum equals to the final momentum. The initial momentum involves the bullet and the block, so the mass of the bullet times the initial velocity of the bullet plus the mass of the wooden block times the initial velocity of the wooden block. And this is, before it starts moving. So there are two components. I think we should call this before motion. Initial velocity before motion, and this is initial velocity after motion. And so we have initial velocity 1 and initial velocity 2. That's for the wooden block. We want to be very careful about that process. And so this one was actually the initial velocity 2. This is the initial velocity after collision. So after they collide, that's going to be the initial velocity. So, we go back and say the fast initial velocity. This is obviously going to be 0. As you can see, if you go back, you see that this is 0. And then we make that equal to the mass of the bullet. We're looking for this motion there, so mass of bullet, and the final velocity of the bullet after it comes out. And then we have the mass of the wooden block times the initial velocity of the wooden block, but this is the second initial velocity, not the first initial velocity. So you have to make that distinction. Our goal is to solve for this number right here. So we're going to move this one to the left. We're going to move the momentum of the wooden block when it's initially moving to the left. And so we have mass mb vb final equals to mass of bullet, velocity of bullet initial, minus mass of wooden block, velocity of wooden block initial. These are the two momentums. We're subtracting them from each other. And then, of course, the next part of the problem is that we'll divide everything by the mass of the bullet. So by the mass of the bullet, like that. Okay, so we're dividing everything by the mass of the bullet. And then in the next page, to get the final, so just want to make sure, final velocity of the bullet becomes equal to, notice these two numbers are going to cancel out, the mass of the bullet and this mass of the bullet. So we're left with the simplified part of the problem, VBI minus mass of wooden block over mass of bullet times the second initial velocity of the block when it's swinging. Remember, initially the block is like right there. Okay, so its initial velocity before it swings is just 0 meters per second. And then when the block starts to swing, it has kind of like another initial velocity, because eventually once it swings, it's going to come to a stop. Okay, so this is kind of like its final velocity, and this is the initial when it starts to swing. That's why we're calling it subscript 2. This is the initial before any impact, before any impact. So we call it 1. Next thing, we plug in the numbers. So we have 450. So this one is going to be the initial velocity of the bullet minus mw over mb. We did solve for the second initial velocity of the bullet, of the block, which is 2g hf radical. Okay, final. And so, we have 450 meters per second minus 1 kilogram over the mass of the bullet, remember, was 0.005 kilograms, and then radical 2 times 9.8 meters per second squared times the height, which happens to be 0.0038 meters. So that's what we have right there. And then when we simplify the problem, this involves a lot of decimals, so we have to be very careful about all the steps. We have, let's see, we're going to have 1 divided by 0.00, oh wait, 1 divided by 0.005, and then multiply that by this radical, which is 2 times 9.8 times 0.0038. Then we have to subtract 450. So we get the final speed of the bullet becomes equivalent to 395.42 meters per second. So this is what's happening to this problem. Just as a recap, we have a block and a bullet. The bullet is fired through the block, it pushes it up, so the block gains some type of momentum. Kinetic energy becomes potential energy, final potential energy. We use that to simplify the initial velocity of the block when it starts to swing up. Of course, the final velocity of the block when it's swinging is going to be 0. And then we use the law of conservation of momentum of the system before collision and then after collision, and that gives us the final velocity of the block. Hope you enjoyed the problem. Feel free to ask any question, send questions my way, and have a wonderful day. Okay, thanks, bye.